So first, maybe one slide on me. So as I said, I'm a machine learning engineer here at Innovex. So I work a lot in the area of data science and data engineering and with the Python data stack. Innovex, we are like a IT solutions company. So we implement IT projects for usually big corporate customers. We have like one area which is application development, then we have IT operations, and then we have data management, which is the department that I'm part of. And if you want to know more about Innovex, the head of data science, Florian Wilhelm, he's also here with us. He will be available in the chat. So you can ask him questions about the company or about data science or anything you like during the talk or after the talk. Yeah, that's it with the slides. So let's directly start with the presentation here. So what is Databricks, first of all? So Databricks is a managed Spark service. And what is Spark? Spark is like a open source application, open source framework that is used by data engineers to create applications that are able to process massive amounts of data by parallelizing the entire data processing onto multiple nodes, onto multiple machines within a cluster. And with Databricks, you have a cloud service that basically creates this cluster for you. So you have the ability to create a cluster with a few clicks and execute some of the execute your Spark workflows. So when you are in Azure or in GCP or in AWS and you open up a Databricks workspace, you can get it, and you get basically this landing page that we see right here. And on the left, we have like a navigation bar. And the first point that I want to show you here maybe as an introduction is this compute page, where you can actually create a cluster. So you can here click on create a cluster, give it a name, say what runtime you want to have, which basically means what Python version you will have, what Scala version you will have, and so on. And then you can decide like how big your cluster should be. So if you disable auto-scaling, you can say, okay, I want to have 8 workers that have like, for instance, 16 cores or 32 cores or 64 cores. And you can also, for instance, enable auto-scaling so that depending on the load, you get more or less workers. And if you create such a cluster, you can go here on the Workspace tab and actually work with Jupyter notebooks here. So here is an example. So you would create a cluster, you would attach the notebook to this cluster, and then you can actually write Scala code, which is the language that Spark is written in, but also Java and obviously also Python, which is like the data engineering, data science language. And here is a small example. You can like read a file, you can do some filtering on this file, and then you can write out the results. And this can be done now, for instance, this can be done in an interactive way. So basically, if you are a data scientist, you can work with hundreds of terabytes of data, which is pretty expensive in this case, but it's possible with interactively with a Jupyter notebook in this Databricks workspace. If you're not actually interested in working so interactively, which is like when you have a real data engineering application, you would obviously not use you wouldn't create a cluster here and attach a notebook to it and run a notebook. But what you'd rather do is you would go into this Jobs tab. So in this Jobs tab, you have the ability to create a job, which basically also comes with a name. It comes with a point of entry. So a point of entry can be a notebook where you have here like your application packaged as a wheel or a jar, and then you're importing it from a notebook and then just like running the main method. Or you can also directly use a jar or a Python wheel and so on. You can define a cluster here. So you would, basically here we would come to the same page as we see before, where we can configure our cluster. And then you have a job. And when you have a job, you can basically run it either now, or you can give it a schedule. So here on the right, we can like click on this page, and we can say, okay, we want to schedule it that this job runs every day, every hour, every minute, and so on and so forth. Another pretty new feature now here in Databricks is that you can actually have multitask job, what they call it. And this is that you don't only have like one notebook and one cluster configuration that you're running, but you can create multiple tasks and and make dependencies between them. So in this case, we have this directed acyclical graph where we see, okay, task 1 and task 2, they both can run in parallel when we trigger this job, and once they both successfully finish, task 3 will run. And this is actually pretty new in Databricks, and it's already a pretty cool feature to kind of make this task orchestration, this orchestration of these workflows in a data engineering application, better than it was before, right? It's already more powerful than just having like one simple schedule. But for us in our clients project where we were working, this was actually not enough. So this is where actually Airflow comes in. So Airflow is a framework to also schedule such tasks, but it's more powerful, right? So why is it more powerful? You can also have these graphs here. We will see it in a second. And you can make different trigger rules, for instance, for this graph. So you can say that task 3 should actually only run when one of these tasks fail, or it should always run, but after these two ones. You can create these tasks also dynamically. So you can say, I have a list of countries, right? And I'm running a data engineering for the data of a given country, right? I'm a big corporation, so I have multiple branches across the world. And I want to dynamically create new tasks for some countries when I'm introducing, for instance, this feature to a new country or something like that. And if we look at Airflow, it comes with a UI, right? This is an open source tool that when you start up the service, you actually get a UI out of the box without actually having written any Python code yet. And when you write your DAGs, they kind of show up here. And then you have like a list of your DAGs, and you can see like how it is scheduled. So this one is scheduled every week for Monday and Wednesday. You can see if how many were successful, how many runs have failed, and you can trigger them manually. If you click now on a given DAG, and then you will see its structure. So there is a tree view that also gives us an overview about how were the runs. So we've seen here on this date, on the 7th of November, we failed, but the other runs were all kind of successful. So they ran through. And here, this is actually the better view to understand the structure of the graph is this view where we kind of see the dependencies between our tasks. Right, so when we go actually on a task, we can also click on it and get some additional information. So we can also go and see the logs. So this one doesn't actually have any logs, but for instance, if we go here on this one in the middle, this branch weekday, this one has a log, and it returns some information that we actually wanted to return also. So you will see this in a second. So going back to this DAG, so how much code do we need actually to write this DAG? And in a very simple case, actually, this is not so much. So here, this is actually the entire code that I need to create this DAG. And most of this is actually this function here, which I will explain in a second. But basically, we are how this entire thing works is that you are basically importing this DAG class, and then you're opening up a context as a DAG, and you give it a DAG ID. This is something that you need to do. This is called dummy DAG now. You give it a schedule, so which is a cron expression usually, or you can use from Python the time delta, or you can give it a none, which is like no schedule. And then you basically build up with operators these tasks. So we see here, I'm using a dummy operator now for the demonstration, which actually does nothing, but only to show you what I want to do here. Basically here I'm creating a list of these dummy operators. So I'm iterating over a list of countries. And this is on top here, my list of countries. So by this, I can actually dynamically create an operator that would execute something with this country information on top of it. And this could be hard-coded here as it is right now, but I could also load a config file in here. So pretty dynamic. So this is one really cool feature about Airflow, simply that you have this, you can use the dynamic power of the Python language. Also here we have this branch Python operator. This is a special kind of operator, and it receives a Python callable on top of a task ID, as every operator does. So a Python callable is basically a function, and this function, it has to return another task ID. So here it returns either process mon or process wet, as a Wednesday. which are the tasks IDs of the tasks below. And this way, we can actually say, okay, our job runs every Monday and Wednesday, and but I have different processing for Monday than I have for Wednesday. So depending on what day it is, it should either execute this task or it should execute this task. And then at the end, I have another task that's basically, that has a trigger rule none failed. So if none of the tasks upstream failed, this one would execute. So I could write a success file at the end of my workflow. I can also have other trigger rules, right? So for instance, when something has failed, then it should run, or even though something has failed, right? So it should always run, but at the end of the deck and things like that. So this is just a glance of the features that Airflow actually gives us. And yeah, so the thing is, these dummy operators, they don't do anything, right? So what you actually do when you work with real applications, you don't use dummy operators, but you use operators from service providers, right? So there are services for data engineering, right? There are Postgres databases, there is Kubernetes that you can use, there is Databricks, and all of these, for all of these technologies, there are actually operators built into Airflow that you can use to trigger jobs in these services. And obviously for Databricks, there are Databricks operators that I want to show you next here. So if you go into the official documentation of Airflow, you will find in the providers, under the providers package, the Databricks providers, and they have operators there, which is, for instance, here, the Databricks run now operator. And it comes with a lot of arguments that you don't need to understand here. It's really, confusing maybe in the beginning. But first of all, maybe what this operator does, it gets a job ID from a Databricks workspace and then executes this job. So here we actually see when we go into this jobs tab and create a job, then the workspace will give us a job ID, and we can use this job ID in here to basically trigger this job that is predefined. So, and we can either go over these arguments, or we can give it a JSON. And the reason, or a Python dictionary that is basically called a JSON here, because it exhibits this JSON structure. And the reason for this is actually because this operator under the hood uses an API request to basically trigger the job, and it uses the Databricks run now API. And at the end of the day, this will either way, whether you give it as argument or you give it as a JSON, this will be at the end transformed into a JSON that will be used in the API call to basically trigger the job there. And all of these, by the way, all of these arguments, they can all be given over the JSON. The exception is this Databricks con ID, which is here, which is special, and then obviously all arguments that are inherent to every Databricks operator, right? Or to every Airflow operator, like the task ID, like this trigger rule. So all these things, you would pass them not as a JSON, but always as an argument. Anyway, so this Databricks con ID is also one important thing. So in order to use the API, you would actually need to authorize, right? So in every service, when you want to use it, you can generate a token. You can do this also in Databricks over the workspace. You can generate a token. And in Airflow, there is a connections tab. And this connections tab actually is a secret store, you could call it, in order to save secrets there. So tokens for the API calls. And here we have one that is called Databricks default. And under the Databricks default, this connection, I have like hidden my token that I need to basically do the API call to this specific Databricks workspace. And this value here, it defaults to Databricks default. So when I don't specify it, it's in this connection. But when I work with multiple workspaces, which might be the case in like complex structures in corporations, then you would have different connection IDs for the different workspaces and the respective authorization there. Another operator that I use more often is actually Databricks SubmitRun operator. It does the exact same thing as the run now operator, but it does not assume that a job has been created by you manually or in some other way in this workspace. But what you do, you give it the entire job definition with the operator. So you can say here, I need a new cluster, and It should have like 2 workers and the Spark version, and this is like the notebook that I want to execute, and so on and so forth. So basically the feature, also the functionality is the same, but you are defining this job in your Databricks, in your Airflow code, or you're taking it from some config file or whatever. But it's not like predefined in the workspace. So that's the major difference between those 2 operators. And it also uses the API, obviously, so this runs submit API. And what I also always find better than looking at like these arguments, I find this pretty confusing, is I actually go and look at this jobs API, right? So when I'm interested in creating this JSON dictionary for the call, I would actually go to the official Databricks documentation and look at the run submit documentation. And here below, I actually see the request structure that I need to pass for this operator, so that it can actually trigger my Databricks job at the end. So, and this is actually what Databricks provides us out of the box in a combination with Airflow, and this is already a lot, I think. It's pretty cool. But in our client's project, this was not enough. So what when you look at how many different things you can do with the API, so you can create jobs, you can like list jobs, and this is only the jobs API, right? So there is a bigger abstraction here. So we have not only the jobs API, but we have also like clusters API, file system API. We can manage our tokens over the API permissions. So we can do a lot of things over the API, but not with these operators. So what we wanted, for instance, to do is we wanted the ability to write a success file out of Airflow into the file system. Or what we wanted to do is we wanted to create one all-purpose cluster, and then execute many small tasks on this all-purpose cluster and then finish it off. Because the way how this jobs call works is that every time you call it, a new cluster gets spins up, then the task gets executed, and then the job is deleted, and the cluster is removed. And then the next task would come in, and then you would again create a cluster. And for big jobs, that's fine. But if you have like many small tasks, you might want to, for instance, create one little bit more expensive all-purpose cluster and then submit these jobs once on it and then finish it off. And to do this, we wanted to do this out of Airflow. So we looked actually on how the operators of Databricks have been implemented, so that we can like create our own operators that give us this ability. And this is what I want to show you here next. So we have called it like this generic Databricks operator. And in order to create an own operator in Airflow, what you have to do is you have to import this base operator and then subclass it. And when you subclass it, the one method that you must implement is the execute method, because this is the method that is basically defining the logic whenever a task is triggered. So what did we do here? So we are subclassing this base operator, and then we are creating a constructor. So this is the stuff that comes in when we are defining our DAG, when we are defining these operations. And what we say, okay, we need a request type, an endpoint, and a request body. So all the things that you need to actually make a proper API call, right? And then we have this Databricks con ID that we need. And then one very important thing is that you also allow for keyword arguments, so that you can basically instantiate the parent operator, which comes with the task ID, which comes with the trigger rules, which comes with all of these arguments. And here, nothing special happens actually. So we're just like creating these attributes in our class. And then what's interesting is this thing here. So this Databricks hook is something that this Databricks operators use. You can import it also from this providers package from Databricks. And you use this hook in order actually and give it this con ID to actually establish this connection, right? So the hook takes care of retrieving the secret, and then it actually gives us this do API call method. And then when you have this do API call method, we can pass in the attributes and do the API calls, right? And everything else is actually just nice to have, I would say, right? So we are logging here, like how does our request look like? Then we are like doing the request, we are like doing the API call, and then we are logging the response. And that's actually it with respect to this generic Databricks operator. So now, like, how would you use this operator? So for instance, we can have a look at DBFS API here, and we can have a look at how should we, how can we like create a file, right? So we can look at this put operation, which tells us how to create a file. So we need this endpoint, we need this method here, and then we need this request structure. So we need a path, we need, what content should it have, and whether we should like override or not override the file if it exists. So, and this is actually exactly how we use our operator. So we have this intro code to like create any bag, and then you give it a task ID as any operator needs, and then the request type and the endpoint, and you can look all these things actually up simply from the documentation, and like now create a success file at the end of your workflow in this Databricks file system, right? In the file system of the Databricks workspace. And yeah, here we are creating like an empty file in this path. And one detail maybe, but what I find pretty cool, some pretty cool feature here in Airflow is that we can actually use variables when we pass in these strings. So Airflow has the ability when you to like render Jinja templates to substitute them, and when we do this, this bracket ds bracket, this will actually get substituted for the date for which we are running. So there is also documentation on this. We can look it up, and we can see here are a lot of different variables that come in Airflow, and we can use them basically in the strings that we provide to like substitute the values. So here we can substitute it for the date that we are running for. Right, so this way we can not only create a success file at some specific place, but for each date when we run it at a different place. And the only thing that we need to do in our operator to allow for this is implement this template fields attribute and tell it which argument is templatable. So which argument, where can you substitute these templates? And I call here, it's called request body. So this means that everything that's in here passed as a string gets substituted in this way. Endpoint and request type would not be substituted, only if I would allow for it, but the thing in this context, it doesn't make any sense. So we don't have that here. Yeah, so this is actually pretty much it with respect to like the basics about it. If you're going to like have more complex use cases, for instance, if you want to create a cluster and then submit jobs to it, then things become a little bit more complicated. So for instance, we have also written this create Databricks cluster operator, and it uses already a specific API endpoint and a specific method, but then it does a lot of other stuff, right? So for instance, we want to wait until the cluster is created before our next task starts. So we are like running and asking for the state of the cluster, whether it's like created or pending or running. We can also implement this onKill method. So how should the operator behave if you cancel a task manually? So in this case, we want to delete the cluster then. And once this cluster is created, how can you actually use this Databricks operator in order to submit jobs to this specific cluster? So this is also possible, and something that we really use in our project. And it would be a little much for this talk, but I invite you to like have a look at our blog post. You will find it when you like Google for Airflow and Databricks. And here we are actually explaining also all these details. So we have, besides like some suggestions as a tutorial how you can get started with Airflow if you're not familiar with this framework. You will see how to set it up. You will see this generic Databricks operator, how to create that one, and also we have like these implementations for specific use cases. That's it. So I hope you enjoyed the talk. I hope you could take away something from that. Most importantly, like what's possible. I think this is like what you can take out most of like talks, short talks like that. And yeah, I'm happy to answer some questions if you have. Thanks a lot.
Hey, Alan. Thank you very much for the presentation. Very nice. Just give me a second to look out for some questions. Your colleague Florian was also so nice to answer already a couple of them. For everyone who maybe jumped in later, no worries. So all the sessions are recorded, so you will be able to watch them on demand afterwards. So let me see. There was one question from Igor, and he had a small discussion with Florian as well. He was asking about, do you run Airflow locally? But apparently you are obviously running it on the cloud and using Docker for that, for example. Do you want to add something to that?
Yeah, so for the presentation, I have ran it in local mode. But usually you wouldn't do that, right? So usually you would have it in Docker, then you would deploy it to a Kubernetes cluster, depending on what cloud service you are. So for instance, in the GCP, you have, I think it's called Cloud Composer. So this is a managed Airflow service. So this is where you can run it as well. Yeah.
Okay, thank you very much. Then there is a question from Pierre. He's asking, how do you optimize the performance with large data amounts?
Yeah, I mean, this is a very, very big question. So I think you cannot also even answer it generically. So one important thing maybe here to just make clear, because I think sometimes people don't get that right. In Airflow, you're like never processing any data, right? So Airflow, it's actually operating in a more lightweight environment. And in Airflow, you're only having the scheduler that is like looking, okay, what task do I need to trigger? And then this data processing, this happens somewhere else. So in our case, it happens on Databricks on a completely different environment, completely different cluster, totally more beefy machines, more power. And then you would optimize, the performance there, basically how you would optimize any Spark application. So this has like not much to do with Airflow or anything. It's like any Spark application. There are methods of optimizing it by looking at the Spark UI, for instance, and looking at bottlenecks there, by increasing the size of the cluster, right? So if you like just throw more money at it, it will run faster until some point. And yeah.
What would you say, like when we talk about optimizing, or what would you say have been some challenges in your project, in specifically this part in using Databricks and Airflow?
Well, so for instance, I worked on a project where we are, for instance, also migrating existing applications from on-premise to Databricks. And these applications are simply also in very different states. So it's really, really hard. They are sometimes very, very big, and it's actually hard to get around there. And also, if you like want to optimize something and you work with the Spark UI, you like get like hundreds of tasks that you can have a look at, and you can optimize every one of them. And this is really untraceable as like with a couple of people. So what we were doing there is we were like looking at the bottlenecks, we were looking at what is taking most time and focusing on, for instance, these parts.
Yeah, okay, thank you very much. Chris is asking, is Databricks similar to Data Factory?
No, Airflow is similar to Data Factory. So I haven't worked with Data Factory, so I can't tell you much about it, but I know that Data Factory is like also a orchestration framework, so you can basically use it to trigger Databricks jobs there, as you could use Airflow. But I think Data Factory is a lot more clicky. You use it more in the UI, so it's not really Python code and not so dynamic. But for instance, it's a managed Spark service in Azure. So when you are in the Azure cloud, you can just spin it up and you can use it. And Airflow, on the other hand, I'm not aware of any managed service there. So we use Airflow there and on a own Kubernetes cluster, which comes with all the overhead of managing it on your own, right?
Okay, thank you very much. Nick also had an interesting question in the chat. He's asking, what does your preferred data stack look like, including the ETL, and how does it perform at scale? Examples, terabyte processing per day.
Sorry, I didn't get the question completely. So what my favorite data stack?
What does your preferred data stack look like?
My preferred data stack. I mean, it depends on the use case, I would say. So one is obviously Databricks and Airflow, which is pretty cool, or Spark and Airflow, which I think is very powerful for like this when you are building like data engineering applications, like really products that run like on a continuous basis, and you're not like looking much into it. You're just having your regular monitoring. When you're working like more exploratively, right? So when you're like creating this application, then what I find cool in Databricks is that you can work interactively there as well, and you can test your code right away. Yeah, but this is also when you're already pretty much going into a product. If you're like working as a data scientist, so even the step before having a product, then you would probably use the regular Python data stack, right? So you would work with pandas or maybe with Dask, which is like a scalable pandas, and NumPy and all these things.
Okay, thank you. Leah has a question. She's asking, how many workers can you have per instance in Databricks?
Per instance, so I mean, I'm not sure if there is a limit, but you can have a lot. Like you can also have like 100 workers. I think it's not limited by Databricks. What I know is like in at least in Azure, you have like a quota, and it's defined by your administrator, and he says, okay, you can have like 3,000 cores actively running in parallel. So then you can spin up in this Databricks cluster up to 3,000 CPU cores. But this quota can be increased. So we have also on one project like a quota of 10,000 cores. But if there is some limit from Azure or something like that, I can't really say, but it's pretty big then, at least, right? So yeah, you can have like very big clusters there. And I think it's not limited by Databricks, but by the cloud provider who gives you the machines that you're actually using, right, for the operations at the end.
Okay. Then another question. What would you say would be, let's say, some features or functions that would even make your life easier with Databricks or Airflow? So what maybe doesn't work that well, or what could you imagine that could be better in the future?
Yeah. So I think personally that when you look at the UI of Databricks and you work with it, it's very tailored towards this data scientist workflow, right? So, but it's not really very, very good in respect to like integrating someone who's working on a real data product. So you would usually not develop with notebooks, right? So when you develop an application, you have your PyCharm, your IDE, like whatever IDE you're using, and then you're like packaging this and deploying this, and then you need to test it also, and you want the ability to like deploy to this environment, but not in a productive really way, but in a like semi-productive way, so that you can test your feature that you're working right now on. And I think all of these things they're getting there, but they're not like done really, really well. I think, and they are working on improving that. So, for instance, with respect to this task orchestration, it was like a couple of months ago, you had only this simple scheduler, and then now they introduced this more complex task-based scheduler of the dependencies. And I think Databricks also seeing these points and like improving upon that. But right now, I think it's pretty much also tailored towards this data science workflow, although it's a very, very powerful data engineering application because it's has this optimized version of Spark as well. So Spark is usually running faster on Databricks than on in its regular open source version, and this is probably why most companies use it. But like the UI and everything could be tailored also more towards developers as well.
Okay, thanks for that. Then one question, maybe there is a small discussion between Jeff and Florian in the chat regarding Python. Jeff is a beginner and starting to learn Python. There is a lot of people out there starting to learn Python, or basically starting to learn programming by learning Python, because it's just that popular nowadays again. How was it for yourself? Like, did you first develop an interest in software engineering? You have your master's degree in computer science, I guess, and you then basically, or let's turn it another way around. Like, did you first develop interest, let's say, in machine learning, and then kind of got a track on Python, or did you first jump into Python and then went to machine learning? And how was it for yourself? And what would you advise to beginners how to start? because there's so many possibilities how you could start to learn programming in Python specifically with all of the different use cases.
Okay, good question. Yeah, so I mean, I had a study program that at the end of the day required me to also hand in like projects that were programmed. So I had to learn it. It was like also mandatory in a certain way. And I mean, I studied information engineering, which is like very broad. So it's not only machine learning, but it's also like statistics. And yeah, so at the end of the day, you have a lot of use cases, not only machine learning that you would need programming for. And I started learning it simply because I was aware that this is a very important skill in whatever I want to do. If I want to be a statistician or I want to be like a machine learning engineer or anything. And so this is why I started. And then I kind of like got into it. So I actually later became more interested in this programming part than actually in the statistic part. So I also learned C++ later because I was interested in like how is it going on a little bit on the low level. Because in C++ you have like crazy methods like of optimizing actually your code that you don't have in Python. And I think one thing comes to another. If you like to like puzzle and like get your head around things and understand like it's like a logical game, right? Then you will, for whatever reason, when you come into programming, it will just like catch you and you will just learn it by yourself, kind of. This is at least how it was for me. So.
Okay, very cool. So I don't see any more questions in the Q&A tool, but maybe if you want to share with us a bit about your personal or about your usual work day. So what types of projects do you work on? And are you looking to increase your teams? Do you look for new colleagues? If yes, how could they apply? And so on.
Yeah, sure. So maybe the first part of the question. So my regular work day is like I can come to work. Mostly it's now at home, and I usually have a daily. So there's at least one meeting per day. This is also something that I learned when I came from the university and started working in industries, that the communication actually with other developers and with other stakeholders is a very big part of the job. That I actually wasn't also aware of that much, but I think it's pretty cool, right? So I like to talk with others also about problems. You can learn from them, and you can help them. And then like, I think, like 60-70% is really like coding. So you have discussed your problem. You have like a project management tool. It's called like Jira, and there you have like the tasks that you like created in your meetings. And then you kind of pick up your task, and then you can just start working on it and code on it, and ask people about their opinion on it. So they will review your code before it gets like merged into the main code base. So this is about how like my job looks like. And of course, we are like constantly growing as a company. So we have like a lot of projects where we need good people for. And if you're interested in, we have like Florian here, so you can you could text them in the chat. You can also text them probably outside of the chat, also via his email. You can text me. We obviously on innovex.de we have our career landing page where our jobs are written out, and you can have a look at them. So we are not only having data jobs, right? So we have also application development. We have IT operations, which is the entire part about like, okay, I want to deploy a Databricks workspace, or I want to deploy an Airflow, right? This is the operations, the IT operations part of it. And we obviously have a lot of data engineering and data science projects and need people there.
Okay, that sounds cool. Alan, that was a very nice discussion. We have been a wonderful speaker and a wonderful guest, so thank you so much.